Okay, so there are a few different ways that you can see this topic presented in your homework. You can have just a straightforward square root of some positive number to a power. You can have a negative square root of a positive number to a power. Or you can have the square root of a negative number to a power. So there are a couple of ways that you can do this type of problem. You can either treat this 3 to the 4th power like we did if we had an x to the 4th power, where we wrote out all of our 3's and pair them up and pull out any pairs to the front. So if you do it that way, I have 4 3's, I have a pair of 3's, a pair of 3's, and no 3's stay underneath. So that means that I have 2 pairs of 3's, or 3 squared, that comes in front of my radical, and then there's nothing left underneath my radical, so I don't have to even write it. 3 squared is 9. So this first problem, the square root of 3 to the 4th power is 9. Same idea is happening here, except now I have a negative number in front of it, so ignore your negative for a minute and just deal with this. Well, we already did that. We wrote out our 4 3's and paired them up. So I have a 3 squared that comes out front and nothing left under my radical, so I don't have to even write my radical. But there's still that negative symbol in front. So keep your negative there. 3 squared is 9. This is negative 9. So the only difference is if you have a negative in front of your square root, that means you need to have a negative with your final answer. But there is a difference between a negative in front of your square root versus a negative under your square root. In this case, if the negative is under your square root and that number is odd, it would be no solution. But that shouldn't happen on your homework ever. So, as long as this is an even number, remember, I'm sure you've heard this, double negative equals a positive. So, if this is an even, that means I'm always going to have a bunch of pairs or a bunch of double negatives, so that all of my negatives are going to cancel each other out to be positives. So, as long as this is even, then your negative does not matter and you can just ignore the fact that it exists. Because an even exponent means that it's going to be a bunch of double negatives. There's never going to be a negative that doesn't have a pair. So all the negatives will cancel each other out. So same exact idea as before. Now I can just write out my 4 3's, pair them up. So I have 3 squared come in front of my square root, nothing left underneath. Actually multiply it out, 3 squared is 9. So as long as this is even, the negative under your square root can be ignored and dropped. Another way to treat this problem is, remember, we can convert this to an exponent. There's an implied 2 here because it's a square root, and this would be 3 to the 4 over 2 power. This is the rule we're using. So 4 over 2 is the same thing as just a 2, so 3 squared is 9. If you don't want to have to write out all your numbers and pair them up and then pull them out, you can convert to an exponent instead, and these should end up being fractions that simplify to a whole number, just for this topic on Alex.